Hello friends, welcome to another video tutorial with Can the Rusi data, and today we're basically going to look at vectors in physics. This is in accordance to your responses, your comments on my other video, and due to your requests in my WhatsApp inbox and Facebook inbox. So I thought, yeah, today we can look at vectors and maybe solve a few problems that might be brought in your exams and everything. So if you want more of these videos, please ensure that you subscribe to this channel, hit the notification bell so that you don't miss any of the videos that we make, and make sure you also hit the like button to show support to this channel and the society at large. So let's get straight into the basics of these same vectors. So basically, we know that vectors are physical quantities with both magnitude and direction. So for any quantity, any physical quantity to be called a vector, it should be composed of magnitude and direction. And an example of these same vectors is force. Force is a very good example of vectors. Why? Because force has got magnitude, which is a mass, how heavy the thing is and everything, but it also has direction. You can never say something pulling or pushing in no direction. That wouldn't be a force, and it just wouldn't make sense. So force is a very good example of vectors, and I have insisted on using force because this is the principle of what we'll be solving and everything in this same course of the day, and this same course of the topic vectors. So if you don't want to have problems with solving vectors, you have to know these two structures here. This one is a Cartesian plane, which is also known as an x or y plane, and we know that it is composed of two axes, which are the y-axis and the x-axis. So this Cartesian plane has four quadrants, and we know that this line there in the x-axis going to the left is a negative. So any force going in that direction will be negative, and any force going in the y direction but down is also negative. The two forces going to the right and up there are positives. So that's what we basically have to know there. Then again, we have to know this basics of a right angled triangle and know what this formula, what the role of this formula is in vectors. So we know that this is a right angled triangle, yes, and it is composed of three sides, which when formed, it forms a 90 degrees angle. That's why it's called a right angled triangle. And these three sides are the hypotenuse, the longest side, the opposite. It is called the opposite because our angle of interest faces that same side, and the adjacent, which just lies, which is a line along the two angles, the 90 degrees angle and the angle of interest. So basically, if you want to understand vectors and apply them in the right angled triangle, we first have to know what SOHCAHTOA is in the right angled triangles and everything. So how it is that SOHCAHTOA is cut into three. So means something else, car means another thing, and toa is also another thing. So for instance, if we want to find the soccer toa, so means s sine theta, which is equal to opposite over adjacent, and this is the formula here. So sine is equal to, sine theta is equal to opposite over adjacent. And when you are applying this to vectors, just know that the hypotenuse is the resultant force. So the hypotenuse is the resultant force. So basically, when we're applying this formula to vectors, when we apply so and everything, we should have in mind that we want to find the resultant force. But how so comes into play, the sign comes into play, it helps us identify the y component of the force when we want to find the resultant force. So this sign helps us find this side there, the opposite side, which in here, if the diagram is drawn like this, it is force in the y component. Sorry, let me just do this. So force in the y component. Sine always helps us find the angle, or not the angle, but the force which is opposite to the angle of interest. Get this from me. Force of the angle which is opposite, force of the side which is opposite to the angle of interest. So for example, our theta is there. So this sign will be determined by sine theta, which is equal to opposite over adjacent, or when you apply it to vectors, it is sine theta is equal to Fy over T, which is the resultant force there, the tension force in the resultant force. So how we write the formula for the y component, or the formula for the side which is opposite to the angle of interest, we write it as, in this scenario, it will be Fy, force in the y direction, is equal to T, which is our resultant force, sine theta. That's how we find that there. Then when we come to car, which is simply cosine, car is cosine, and the formula is cosine theta is equal to adjacent over hypotenuse. So the adjacent, we said it's just the line which the two angles, the angle of interest and the 90 degrees angle, lie. So basically it will be this line here, which will be the adjacent. And if we look at this angle, right angle triangle in the right direction, it faces this direction, then that adjacent will be the force in the x, force of the x component. So basically how we find it is cos theta is equal to fx over t, and to find the x component, since the tension force here will be found by the sum, Pythagoras theorem formula, making the sum, the square root of the sum of both the y components and the x component. So for us to find the x component, we'll say fx will be equal to T, which is this tension force here, cos theta. Cos theta there. Sorry, the paper is moving and everything. Yeah. So that's basically how we find it. And to find the tan it's simply tan theta is equal to opposite over adjacent, and we use the tan mostly when we're trying to find the angle. We've already found the magnitude of the resultant force. Now we're finding the angle of which is the direction of that same resultant force. We use tan, and it will be theta, since the angle of interest is theta, will be equal to f over y. Since we want that, we take tan to the other side and becomes tan inverse close brackets fy over x over f of x. Basically that's that. So that's what we do. So if you come to understand the basics for this, you get to solve vectors without any problem. So now to find the magnitude, since we've these two formulas here, these two first formulas only help us to find the components of the resultant force, the y and x component of the resultant force. So to find the actual magnitude of the resultant force, we use the formula for the Pythagoras theorem, which is h squared is equal to opposite squared plus adjacent squared. And in the end, we know that for us to find this, find the answer of the hypotenuse here, we have to get rid of the square root and introduce the square root this side. So basically that's how we find the magnitude of the resultant force. And here in the right formula, it will be F resultant force is equal to square root, since you square root here to get rid of that 2, that other side, square root of the x components plus the square root of the y components. That's how you find the magnitude of that. So these two basic formulas will be the defining moments. After finding the x components and the y components, we then find the magnitude by using the formula. Then we find the angle or of direction of the resultant force using this formula there, which is theta is equal to tan inverse f over fy over f of x. So that's that.